Hi everyone, my name is Zsombor, and I am quite nervous because I haven't been talking in front of people for a long time. And if you can't hear me, please in the back let me know if it's okay. So I will be talking about, I'll be looking that way, that's not good, I will look this way. So I will be talking about Swift as a programming language. I will introduce Swift also and tell a couple of things about Swift. Why is it interesting? Why do I like it? And I will do one thing in an imperative and a functional way and try to compare how does it look like, how does it work, how fast is it, how much memory is it using. So about Swift, this is the marketing from the Swift side, which I kind of agree. I really like Swift, so I'm afraid I won't be able to really critique it much, or I'm biased a little bit. I really enjoy working in Swift. So I will say only good things, alright? So you should check out the internet for all the bad things which people are writing about it. So Swift is a general-purpose programming language built using a modern approach to safety, performance, and software design patterns. They mean here that the language is really meant to be, first of all, but very fast, but also very safe in a way that if your code compiles, then it's quite likely that it will not do anything terrible and will not crash and stuff like that. This is the best available language for uses ranging from system program to mobile desktop apps. So the goal for Swift is to be really usable for system programming, even writing maybe kernel stuff, operating system stuff, till scripting. I don't think it's there yet, but it's a good goal I like, and they're working on it. And the main goal is to try to write and maintain correct programs, so it should be easier for the developer. And here is the sentence. This is from the Swift side. Opting for safety sometimes means Swift will feel strict, and that's true. Somebody was saying that sometimes programming in Swift feels like doing your tax or something, because sometimes you really have to go through a little bit too much code to make it do what you want, to make sure that it's okay what it is doing. But I actually like this. I realized more and more as I get older that if a compiler is not there to hold my hands, then I will make all the mistakes possible. So I really enjoy having a compiler which warns me and makes errors when I do something wrong. They claim, and I think it's measurable, that because Swift is made by Apple to replace Objective-C and C, so to run on these mobile devices, which are quite fast now, but still they really needed it to be fast enough to be able to use it instead of these. And decades of advancement in computer science. So Swift borrows, of course, from a lot of other current languages, and also uses a lot of things which were developed in academia maybe in the 80s or 90s, but now we can use them in programming languages, which is good. And here's a list of the interesting or extra features, but I think I will skip this. You can probably I will probably put up the slides later. So here's the thing we want to do. I will start doing this, and then meanwhile I will talk about some features in Swift. So the task I came up with is that we have metadata, a JSON file with a lot of photos, which I downloaded from a service called Unsplash. So I have a bunch of photos, not the photos, but the metadata about the photos, the size, the photographer, the description. And we want to go through these photos, and we want to find the photos which are in portrait orientation, so the height is bigger than the width. And we want to get the photographers of these photos and get the Twitter handle, the usernames of these photographers, but we want them sorted and we want them unique, so we don't want to include the same Twitter handle multiple times. So that's what we want to do. And here's the JSON. I will show how to parse JSON in Swift, even though that will be the same. That doesn't make sense to do it in an imperative and functional way. There is one way to do it now. I just want to show it so that we see some Swift code. Here is a JSON. Here is a struct where we want to parse into. So it might be too small, but it's basically just the things which are in this JSON: the ID of the photo, date, width, height, description. There are some URLs to download it. There the user. There is the username, Twitter username, links. It does not have everything from the JSON, but you don't need to. It will only parse out the things we need. And here I want to talk about why is this a struct and not a class? Because in Swift, as most object-oriented programming, there are classes, but there are also structs, and the structs are very similar to classes. You can basically do almost everything with structs than you can with classes, except you cannot subclass. But the other big difference is this thing, the value versus reference types. Types in Swift fall into one of two categories of value types, where each instance keeps a unique copy of its data, usually defined as a struct in our tuple. I don't know. The second, reference types, where instances share a single copy of the data, and that's usually as a class. So when you have a reference type, then you basically have a pointer to the single thing. If you pass this thing over to some other part of the code, you pass the pointer, and then they actually access the same thing. That's the usual thing, I think, with object-oriented programming. But Swift is very heavily relies on value types, where you actually pass a copy of the thing always. You don't pass a reference to it, you always pass the whole thing. And here they say that the reason to use value types is because then it's easier to reason about your code, because you know that nobody else can change things under you. Because you pass the copy, nobody will do something bad and then your copy will change, because they are all a copy, so they are all different instances. So especially in multi-threaded environments, this makes things much easier to understand what is happening. It's much less likely that you will have some kind of state leaking over between threads. And what is very interesting in Swift that the basic array, dictionary, and string types are value types. So when you press an array, you press the whole thing, instead of a reference, which I'm not exactly sure about how this works, but they do something under the hood where they only copy stuff when you actually change it, so there is some copy on write. But that's specifically, I think, only implemented for the array and dictionary maybe, so it's not something you get for your stuff, but I think you can do it, so there is ways in Swift to actually deal with this so it's not slow. Since they wanted this language to be fast, and since these mobile devices don't have that much memory, I mean, not as much, so they have to be careful about this, but still, by default, these things are passed by value. So in this case, I would go with a struct, because after I parse this thing, I don't want any other part of my code to start changing the username and whatever. Here is a quick JSON decoding. There is a built-in JSON decoder. You have to give, there's one thing I had to give to say what is the dates in what form are the dates in the thing. And then here is something which you do in Swift all the time, is this e-flat thing. Does this thing have a thing where I can, this laser?
Yeah, there's a red one.
Nice. So there is this call. In this case, I have this JSON in the bundle of the application. All this thing is running on an iPhone, so there is the application bundle. I have this photos.json. This is the way I can get a URL to this thing, but since this file might not be there, let's say, or maybe I mistyped the name, this thing will return the URL or not. And this is a way to handle it. So let's say if I say if let, then this thing will only be true, and then I get a URL if the URL is there. So I will talk about it a little bit later. Same example, there is a similar example. This is a way to actually load in a file into a data object, data contents of URL. This can fail, but if you put this try question mark, then if it fails, then it returns a nil again, which I will talk about. So you can be sure that if I got here, then this data I have. And then here is the decoding itself. I tell the decoder to decode an array of photos for me from this JSON data, and then try to do it. And then if it succeeds, then we get through this if. So if we got this to this point, then all of these succeeded, and we have a list of photos. Otherwise, any of these failed, then I'll just return an empty list. So this is something which is called optionals in Swift. That means that an optional is a type which represents either a wrapped value, so anything, or nil, which is the absence of value. So for example, in our case, the Twitter username of the photographer is either a string or it's a nil if this photographer didn't set a Twitter username. So I know that this thing can be nil, which means that it's not set. It's different from like an empty string. The empty string is set, it's just empty. And for example, here is this function we were using previously, this URL for resource with extension. And this returns a URL optional. This question mark here means that it's an optional. So it either returns a URL or nil if the file could not be located. So this is the main way of dealing with this kind of failure states or when something can return nothing. This is very frequently used, dealt with using optionals, and then you need to use this kind of if-let, or this is the best way to get the data out of it with this if-let structure. So here's, for example, the example. If let JSON URL and this call returns a URL optional, but if I put it in an if-let, then here, this JSON URL is not optional anymore. Then it's the real URL. I can be sure here that I have a URL. And here I know that I don't have a URL. So this kind of way that you're always forced to deal with the option that the result might be nil makes things, at least I feel that it makes things much, so you're forced to deal with these options when you're doing your code. This is when they say that it feels strict sometimes, like I don't want to deal with this, I'm just doing a quick thing and I have to deal with this. There are ways to do that, but I think for me at least it feels really good that, okay, I know that I have to handle the case when it's not there. And I just wanted to point out another kind of interesting thing in Swift, that these parameters actually have two names, you see. So this is a function called URL, and it has two parameters, two strings, optionals. But they have two names. There is one an external name and an internal name. And the external name is called argument label. This is what you have to use when you call it, which makes it sound like a sentence that give me the URL for the resource with the extension. But inside of the implementation of this thing, you don't want to write for resource and with the extension, you just want to use name and text or whatever. So it means inside the function you can use your own short name, so it's not take long, but outside you can present a very nice interface. And these names are mandatory, so you have to put these. You cannot leave. When a parameter has a label, then you have to use it when you call. I forgot to check when did I start. So, okay.
No worries.
I'm slide 10 of 100. So, alright, so let's go back to the task. This is just the same thing. I just wrote it again. So now we parsed the JSON, so we have the metadata of the photos. The next thing we want to do is to find the photos which are in portrait orientation. And here is an imperative solution I came up with. I hope one of you would say that this is totally stupid because then I measured my functional solution to something stupid. So let's see. First of all, I declare a string array. First it's empty and it's a variable because I want to change it. I want to put the Twitter usernames into this as I go through of all my photos. And then I will return it in the end. This will be the result of this whole task. I will go through all the photos. This photos thing I could have, it could have came in as an argument, but I had it as a whatever. So I have these photos, and I have all my photos, so I will go through them. This is the only for in Swift. There is no for where you can var e equals, there is no such thing, they removed it. There was, but they removed it because it's because this is nicer and better. And the compiler can optimize this much more than the regular for var I equals 0 because that can be whatever. So I find this also very interesting that this is the only way to iterate through things. And so I go through each photo. I check if the width is less than the height, so then it's a portrait orientation photo. Here I showed the part of the struct where I have the user, so the Twitter username is an optional. So I have to here use this if-let construct again to get out the username from the Twitter username. So if the user doesn't have a Twitter username, then this will fail, so I don't get into the if at all. So that we just keep that photo. And here is the wonderful sorting and uniquing algorithm I came up with. I will first this thing will be empty, so I will want to insert the new photo to the end, which will be 0 first. And then I have to go through the existing usernames. So this is complicated. I think this is one of the reasons you want to use functional programming, because the imperative version is very hard to even get through first. So I think me struggling with this here illustrates the point. So I have to go through the existing Twitter usernames we have. I go through like this, so I want to use this enumerated thing, which will give me the index and the item. And this is my new username. I go through the existing usernames. If I already find this thing, then I don't want to put it in anymore because I want to have unique. So then I will say that, okay, index for inserting is nil, which means don't insert. Then if the new username is less than the actual thing I'm checking, that means that this is the place I have to insert because I want to have them sorted. So, and then when I have the index for inserting, I'll insert it. So basically, at first it's empty. I find the first photo I want, that I will just insert it, then I have one thing in it. I find the next photo, then I will check, is it the same? If yes, I throw it away. If it's less, then I put it before. If it's bigger, then I put it after. This works. This is not a very good sorting with strings because I should have used something like some standard localized comparing whatever, because this results in things like the capital letters are sorted before the small letters. But anyway, this is the result of this algorithm. You see that we have 34 unique sorted Twitter usernames from photos of 300. And now let's do the functional one. But first, this is the definition of functional programming from Wikipedia. I thought I will read that so I know what I'm talking about. So basically here says that avoids changing state and mutable data, which I think is one of the things which I want to focus on. And also that it means that the functions will give you the same results every time you call them. They don't depend on external state. And I think this changing state and immutable data is one of the things which here we do, for example, with that not using a class, but using a struct, which you cannot, and they're using constants everywhere possible. Here's the functional solution for the same problem. I would rather do it this way. So here is a functional solution to the same problem. First I get the photos, I filter out the ones which have the width smaller than the height. Then I will get all the Twitter usernames, but only if they are not nil. Compact math throws away the nil ones and keeps only the ones which have value. I unique them by putting them in a set and then getting them into an array again. And then I sort them. And that's the same thing. So, I feel like this one, I mean, this is the same in one line. I don't think I would write this in code. This just, I don't know. I don't think I would be comfortable leaving this in my production code. It just looks uncomfortable to me. This I like. This has names for things. I know exactly what's happening. And I didn't write it in the slide, but I was all the time comparing these two, and there was no difference anyway. So the compiler in the end actually produces probably the exact same code out of this. So here we have our two solutions. We have the imperative solution, which basically iterates through one by one and inserts one by one. So I think this imperative solution definitely doesn't do too much unnecessary stuff, because it really goes through, takes every photo once and puts it where it needs to be. So it doesn't go through the whole thing several times. It doesn't allocate more memory to keep copies of things. So I would think that this will be very efficient. But I don't think it's really readable. I had a hard time even explaining what it does. I had to think through exactly how does it put it. Like, we don't want to do sorting by hand. Basically, we are doing sorting by hand. It just doesn't feel really good. This functional solution, for me, it feels too compact, too short. And this feels the best to me. I think it's the most readable, and I think if I look back at it in 6 months, I would know what does it do. Even that I should have put some comments maybe, although I think these are quite straightforward, that probably don't even need that. So I was running these things on my phone, and since I wanted to have a little bit more data, I just made I had 300 photos in this JSON, so I just made it 100 times bigger by just copying the 300 photos. So I thought I would show you how to copy 300 photos, which was not as straightforward as I thought. There is a way to create an array by repeating something 100 times or whatever times, but this is an array. So this is an array of arrays which should be joined to have flattened, basically. But I was surprised that the result was not an array, but it was a flattened bi-directional collection, which turns out is just a view into an array of arrays. So it does not actually allocate any memory, it doesn't copy anything. It's just, if you iterate through this one, you will get all the stuff. So it's kind of, Swift has lazy stuff. This is not exactly that, but something similar. So you need to get and make an array out of it, because I wanted an array. I could have just used this and just iterate through it the same way. It wouldn't change anything, but this was the way to get an array out of it. And now I have 30,000 photos. But, and then here is my benchmark. So I run the thing 100 times, and I check the date before and after, and check how much that did it take. So that was my big benchmark. In the new Xcode, which I didn't really have time to look at yet, which is in beta Xcode, I don't know, 10 something, I don't remember. They have some more stuff to you actually can mark pieces of code, and then the instrument, there is an app code instruments, it could actually measure your code, but I didn't have time to check that, so I just printed dates. So here's the comparison of the imperative solution. Does the thing 176 milliseconds. So so 100 iteration, but I divided it, so it's one run. 176 milliseconds. The functional resolution is 141. So I was like, okay, pretty good. It's not slower, it's faster, not much faster, but I think the readability really makes it worth it. I mean, it would make it worth it that it's faster, but it's also readable and more maintainable. But then I realized that I'm running it in a debug build. So it doesn't do any optimization. So I run into the release build, so it's 34 with the imperative and 25 with the function. So it's still, I mean, it's much faster than the release build, obviously. Actually, not obviously, but Swift does a lot of very strong optimization, which is off when you in a debug build. So it's something which I keep forgetting. Sometimes you even have bugs which are all in the release build, but that's a thing.
But on the other hand, you are comparing two different sorting algorithms, right? Because one is handwritten and one is from like collection or standard library.
You mean that my sorting is...
you're comparing also different sorting algorithms. If you implemented imperatively the sorting algorithm that was implemented in a standard library, which they might be, I don't know, but I also think the second one is definitely better, so I agree.
So yeah, that's a point that maybe this comparison I'm making is not really about functional imperative, but should I use standard library or not? And but what I mean here is that when you are writing your own code, it's really, I think, makes much more sense to just use the things you have, even though like use these kind of pre-made functions and build stuff out of it, and don't try to be smart and do it by hand at least. But let's see the memory usage, because that might be a problem. So here, this is the imperative solution where, in the end, I know that here I know that I have only 34 things in the end. Here we do not allocate basically anything else. So here we only use this, in the end we will have these 34 strings. That's all the extra memory we use. This does not allocate any memory. While the functional solution, it has first this thing where I filter out all the portraits, portrait orientation photos. And that's when I have the 30,000 photos, that's 11,600. From this, the usernames are 5,000, even though then unique are just 34, but I have to first have those here stored. So this definitely will allocate some more memory. Here there is a way in Swift to ask for size of things, it's called memory layout. The stride is number of bytes if you keep it in an array. So because this photo struct is 336 bytes when you keep it in an array, so if I have 11,600, I will have basically 4 megabytes of extra memory, which 4 megabytes is not much, but you might have a critical thing in your app where you don't want to use 4 megabytes. And if you have more images, then of course, or more data. So here, let's just put it again. So this is the first step when I filter out. Here is memory usage from Apple's the Xcode's instruments tool. You can see that the imperative is totally flat. This is running it 10 times because I don't know why I ran it 10 times. Here you can see that the function definitely is allocating and then releasing memory continuously. I didn't have a very good way to measure it, but on the instruments I saw that these bumps are actually 4 megabytes. So it's for every run of this thing it allocates 4 megabytes, and this is something which you have to know in your code if this is, or your case, if this is acceptable. But I was then thinking that why am I using a struct? So I'm using a struct because I don't want things to be changed, basically. But what if you would use a class instead? Then suddenly the photo is only 8 bytes, because then just a pointer to a memory, to somewhere in the heap. And then suddenly my 11,000 thing is just 92 kilobytes. So I run the test again, and then it was only 0.4 megabytes. So simply by changing struct to a class, suddenly I saved basically the memory usage of the functional went to 1/10. And I thought then I'll check the performance too. And the imperative is smaller but similar, but functional is 5 milliseconds, suddenly fifth the time. This was a couple of days ago, so I'm still a little bit shocked by this. And then I went back to this text, and then suddenly there I found this part, because the difference is defined in terms of what happens when you change data. There is one case where value and reference type overlap, when instances have no writable data. In the absence of mutation, values and references act exactly the same way. So if I have a class which doesn't have any changeable fields, then it doesn't matter if it's a struct in a class from the mutability, side effect, state changing perspective. Then it only matters if it's on the stack or on the heap. So is it copied always, or is it just a reference? So in this case, I think it's perfectly fine to use a class, even if you want to make sure that it's not changeable. So here, as you can see, everything is marked with a let keyword, which means that it's not changeable. After the instance is created, you cannot change let things. It doesn't compile, so you just can put in a thing. So my conclusion is that, even though as we talked about, it's maybe not the actual right conclusion, my functional solution here, which used a system library to sort, although actually the sorting is the smallest part because it was only 30 elements. So it's more like the filtering and that logic. So it was shorter, it was easier to write, easier to read. I think it's easier to maintain. It runs faster. It uses a little bit more memory, but if you are careful, then not that much more. So here it is. I actually did the thing because the 34 is maybe too small, so I did something when I added a bunch of random letters to Twitter usernames. So, and then suddenly this is the don't do your own sorting thing. Use standard library. But with 3000 stuff, it's still, So anyway, these are the two things. These are the two approaches, and this was my conclusion, and I think that's all I have. So, if anybody has any questions, suggestions, please.
Does Swift has an immutable set implementation? Because working over array seems, especially when the result you want to achieve is uniqueness of items inside the collection. I think it's better to use some specialized collection to do that case, and probably that could also influence the results a lot.
Yeah, so in Swift, the way it is that these arrays and set and dictionary, if you put them in a let variable, a let thingy, then they are constant, they're immutable. If you put them in a var thingy, then they are mutable. I'm not exactly sure how they do that. Also, because Swift is very much has to interface with Objective-C, there is a lot of thing going on. So this array actually is under the hood, is using sometimes Objective-C, but not always. So there is in the set the same way. But so you can use a mutable set, but in this case, so if I want to check if something is in a collection or not, a set would be probably much faster. But here we don't actually. Here I do it with the sorting. So then I would have to I could first unique it with a set and then do the sorting. Might be faster.
Yeah, it might be a lot because set probably could use some kind of flashes or flash model or something like this. So checking whether username is inside or not would be almost instant. While you have to iterate that array over and over, and probably I'm just interested in how could it look with using set instead of button.
Well, so I'm thinking here that this solution, I'm pretty sure we can make it faster. But that would make it bigger and bigger, and we could use things. So,
I mean, you could walk over all the usernames that you get after getting that username. Then, without caring much about the value, you could just add them to the set over and over. At the end, just convert set to array and return array.
So you're talking about the imperative solution.
Yeah, that part you could get rid of, and still have imperative solution for that.
I feel like that. Yeah, I think we can improve this probably, and I think maybe we could make it even faster. And I think maybe there are some special cases, specific cases when you need to do that. There are some cases when maybe your own, so there's something which is really critical that has to run really fast. I don't think the readability would not improve that much, I think. So even if I would use a set here for performance reason, maybe then I would have to do another pass to sort it. But then I could use the built-in sort, but then slowly we are basically at the same, I think. If I understand what, maybe I misunderstand what you're saying, but yeah, I'm sure that this could be improved, but I'm not sure the performance of the imperative solution could be improved, but I don't think the readability would ever be as good as the top solution. And then what's the point at this scale, I think. But again, we are then going back to are we using standard library or doing it ourselves, and then that maybe in some of these cases that's the real difference and not actually the functional and imperative. But I think the message here is that it's I think you should definitely do the functional, this one first. And then if you see problems later, then maybe it makes sense to do some own, but it almost never makes sense to start with your own iterating through things and putting it. Any other comments?
I have two questions about Swift itself. So first thing is because from how you described Swift and how it was described in this documentation or on their page, this seems to have the same target as Rust, for example, like system level programming language, very fast, performant, very safe. So the first question is, do you know how it compares to Rust? And the second one is how memory management looks like. Is it garbage collected or?
So I never used Rust, unfortunately, but I've read a lot of times that this is really influenced by Rust in a way that they actually are working now to put in that kind of ownership model that Rust has as an option. I'm not even sure I know what does that mean, but Swift it's a kind of garbage collection where it's called automatic reference counting. But every time you allocate something, it increases the reference, and every time it allocated, it decreases, and then when it goes to 0, it cleans it up. So there isn't an independent garbage collector running and stopping the whole thing, but it's just every time you get in and out of methods and functions, it just does this reference counting, which they say that it has a much better performance than an independent garbage collector, even though those are improved a lot recently in the last 10 years. And they say that it has a much smaller memory footprint, so it doesn't need a lot of memory. It doesn't need extra memory, basically. There is a little bit of extra memory of incrementing and decrementing. But sometimes the programmer has to pay attention because you could create a retain cycle when one thing references to one other thing and that references the thing back, and then they will kept in memory forever because nobody knows that they should be, because there is not an external thing which would go through. Swift has a lot of language support to deal with retain cycles. It warns you when it looks like you will get one. You can declare references as weak, which will automatically be nilled out if the other thing goes, but you have to also check if they are nil because the other thing might have gone away. So like if the one thing has a reference to another thing, that should have a weak reference backward. So then this will not be kept in memory, but this has to check if this is still there. Which is sometimes a pain, especially when you do an iPhone app and then you have a bunch of views and screens and stuff, and then you pass things around and you set callbacks, like, okay, I will put you on the screen, call me back when you're done, but then suddenly that thing has a reference on you and you have a reference, so like there is a little pain of that. They have a lot of warnings, they have a memory, retain cycle, analyzer, so there is a price, but it's supposed to be much faster and using much less memory, and they are working now on having an optional ownership thing, which I didn't really understand. And also you can do very low level pointer stuff if you want. So there is a way to actually allocate memory. And I had to do that. I was working on an iPhone app where I want to do some image manipulation, and then I had to go into the bytes. And that was also a little bit painful at some points to try to keep it really type safe and everything is clean and stuff, but I think they put a lot of thought into that one. Yeah. So unfortunately, Rust, I don't know. That's on my list to learn, but.
I've got one more question. It's more like a curiosity. So when you have the unique usernames, when you convert it from the set to array, what is the order? Why do you need to sort it again?
I think the set simply does not guarantee any order.
Okay.
So when the set says that when you get the things out of the set, they are in implementation defined order. So whatever. Swift is open source, so you can look up how the set puts stuff. Probably not in alphabetical order. So
speaking and commenting about what Andrei said, I don't think that even using hash map there in the imperative solution wouldn't be, it will be more readable, but it won't be faster if you need to sort anyway the set, the output from the set. Because you need to do the sorting at the end, which is n or n anyway.
Yeah, but here you're sorting for everyone. Right?
No, actually not, because you're only sorting for those 30-something results.
Exactly. You're doing insertion sort instead of the sorting.
When I have 3,000 stuff, then probably these huge numbers were coming from this. Then I had 3,000 things, and then unicking it.
Yeah, exactly.
Although not, because for the sorting you have to go through anyway. If you don't use built-ins, you could implement a quick sort. You don't want to do that. I mean, you want to, but not if you are paid by the hour probably. But then maybe you do.
If you are paid by the line of code, why not?
Yeah, that might be a good argument for that.
Are there any questions? Thank you very much.